Hello students, നമ്മൾ ലാസ്റ്റ് മോഡ്യൂളിലേക്ക് കടക്കുകയാണ്. സെക്ഷൻ 14.5 സർഫസ് ഏരിയ ആൻഡ് സർഫസ് ഇൻറ്റഗ്രൽസ്. നമ്മൾ ഒരു ഫംഗ്ഷനെ എങ്ങനെയാണ് ഇൻറ്റഗ്രേറ്റ് ചെയ്യാമെന്ന് നമുക്കറിയാം. റിയൽ ലൈനിൽ ഡിഫൈൻ ചെയ്തൊരു ഫംഗ്ഷനെ. സോ ഫോർ എക്സാമ്പിൾ I will go to the next slide. Suppose your function is defined over this interval a comma b, ab to r. This is the real numbers. This is your f of x. X is the independent variable. Y is the dependent variable. X comes here, y comes here. Then we know what is the meaning of integral a to b f of x dx. Now suppose we are in the plane, xy plane. This is x-axis, this is y-axis, and suppose we have a curve. Let us say parameterized curve c, and suppose I have a function f, real valued function f, defined over a region R containing C. So this is the region R. R contains this parameterized curve C, and f is a real valued function. So f is a real valued function. This is the real line. Then you know what is the meaning of integral over C f ds, where s represents the arc length. Okay. Next, suppose you have the xy plane. This is x-axis, this is y-axis, and suppose I have a region R. This is R, and I have a real valued function f. This is the real line. So the function f is a function of two independent variables x and y. So f of x comma y. Z is equal to f of x comma y. And then you know what is the meaning of integral over this region R f of x comma y dA. So double integral over R. Okay, all these things you know. So this is the usual integral, integral a to b, and this is called the line integral, and this is double integral. One is the usual integral, two is the line integral, and three, that is the double integral. Similarly, you have triple integral. Now the concern is, what if my function f is defined over a surface? Instead of a curve like this, in the second case, suppose I have a surface in the xyz space. So suppose that I have, this is my surface, given by given by f of x comma y comma z is equal to constant. That means this is a level surface. I hope you know or you remember what is meant by level surface. And I have a function g defined over the surface. Yes, real valued function. So this is the real line. Okay, Now we want to define something called surface integral of G over the surface S. So surface integral will be denoted like this: integral over S, double integral. This is called surface integral, not double integral. Surface integral over S, G of x comma y comma z d sigma. That is our notation. This is called a surface integral. This notation. Now what is the meaning of this? How do you define? So first we will define what is called surface area. Then we will go to the definition of surface integrals. So surface area. So I will go to the next slide. So surface area. Again look at this figure. I want to obtain the area of the surface S. So what I do is, let me remove my this G. I don't want this G. And look at the shadow region. In the plane Z is equal to 0. Z equal to 0 means xy plane. This is the shadow region. So it will be denoted by, let us say, R. അതായത് നിങ്ങളൊരു ടോർച്ച് അടിക്കുക, എസിൻ്റെ മുകളിൽ നിന്ന് നേരെ താഴത്തേക്ക് ഒരു ടോർച്ച് അടിക്കുക. So I will draw the figure of a torch. So this is my torch. അപ്പോൾ അതിൻ്റെ ഷാഡോ അവിടെ പതിയും. It will be denoted by R. Okay. I want you to go through the textbook and understand what is meant by the surface area of S. How do you derive the surface area of S? So I'll go to the next page. Where is that? Yes, here. Surface area of S is equal to double integral over R. So this is double integral over R modulus of del F divided by modulus of del F dot P dA. So this is double integral. The right side is double integral. Double integral. So what is P? P is a vector. And what is this dot? This is the dot product. And P is which vector? P is a vector perpendicular to R. So this is your vector P. And P is a unit vector. So the thing is that if you are lighting directly from above, then the shadow region will be lying on the xy plane. So in that case, P can be taken as the unit vector K, which is perpendicular to this shadow region R. So this is the shadow region and P can be taken as K. Suppose you are projecting the surface onto the xz plane. So this is the xz plane. So look at the shadow in the xz plane, and you take the unit vector P, which is perpendicular to that shadow region. That means you can take that unit vector P to be vector J. Understand? Similarly, if you are projecting the surface to the YZ plane. Then look at the shadow on that YZ plane, and you have a unit vector, vector P, which is perpendicular to that shadow region R. So vector P can be taken as vector I. So in general, vector P is a unit vector perpendicular to the shadow region R. Okay, so this is the formula for surface area. How do we derive this? I want you to look at the textbook. So surface area of S is represented as a double integral. That's what the advantage is. We shall do problems in the next video. Thank you.
As a